All right, hey, and welcome to today's video where we are actually going to be looking at something very exciting called the Pythagorean Theorem. And in today's video, I'm going to explain some vocabulary and then just actually I'm going to give you guys a visual proof. I'm really excited to prove this formula for you. Now, the Pythagorean theorem is something that a lot of people have heard of. They have heard a squared plus b squared equals c squared. So my goal for today is to explain how this proof works and actually what this picture is even of. But first, let's dive on into some vocabulary. So in any right triangle, and I should point out that the Pythagorean theorem only works with right triangles, y'all. But in any right triangle, the sides which form the right angle, which this is the right angle in my picture, the legs are what we call the sides that form that right angle, okay? So those are called legs. So right here, I'm tracing a leg in red, and here I trace, whoops, sort of trace the other leg in red, okay? So those are the two legs, they make the right angle. Now, the side that is opposite of that right angle, so if you kind of draw like a dotted line away from the right angle, the slanted side is something called the hypotenuse, all right? Now, in general, when we're labeling the sides, this hypotenuse is always labeled side C, like always, always, always. Now, for these right here, you could label this side A and then put a B right here, or we could label this side A and this side B. It doesn't really matter. And I'll point out to you guys a little bit later on in the video that the reason it doesn't matter is because addition is commutative. It doesn't matter which side I call A and which side I call B because I'm eventually going to be adding them up anyways, and order doesn't matter when you add. All right, cool. So now that we've got here just like the vocabulary, I'm actually going to pop over to another slide and kind of explain this visual. So this is me attempting to explain the entire, or prove, I should say, the entire theorem. And again, up in this corner, I'm going to remind you guys that the Pythagorean theorem says that a squared plus b squared equals c squared. Now, I'm starting out here with a right triangle. And again, the goal is for me to be able to prove that this side squared plus this side squared equals this side squared, okay? Now I'm going to put some numbers in first just to kind of give you guys some of the basics of the idea here. If this is a side length 5, if I say this is a 5, and I say that this is a, oh actually let me not make that a 5, let's make that a 3. I'll make that one a 3, okay? The Pythagorean theorem says that if this is a 3 and this is a 4, that this will be a 5. And what we're saying is it's because 3 squared plus 4 squared, so I'm going to put a plus 4 squared up here, equals c squared, which in this case would be a 5 squared. We're saying that 9 plus 16 equals 25. Now I'm going to come back to this. This is true, obviously, 25 equals 25. So I'm going to leave this up here in the corner, and we're going to come back to that at the very end of my proof, okay? I'm going to get rid of them right here for now. And just bear with me while I actually take the triangles here, and I'm going to build something different. Let me get rid of this real quick. So all I'm doing right now is something that you guys are actually going to be doing once you get to 9th grade. And in 9th grade, you have to actually prove everything that you know about geometry. So this is me kind of giving you an example of what 9th grade geometry proofs look like. I got to prove something that I know to be true. Now again, the thing I know to be true up here is that a squared plus b squared equals c squared, and I'm getting ready to try to prove this to be true, okay? All right, let me just move that over a little bit more. Here we go. Now you can see this purple square that I have off to the side, and I want to point out that where I get my purple square is actually right here. See if I move that back right there? And now I want to talk about the area of this purple square, okay? We already said that this side length is c. We also know that it's the hypotenuse over here. This is a c. And anytime we find the area of a square, it's just this times this. So the area of this purple square is a c squared. All right. I don't think anybody's going to fight me on that or be confused with that. The area of the purple thing is simply a c squared. So if this was a 10 and this was a 10, the area would be 100. If this was a 3 and this was a 3, the area would be a 9. All right, cool. So I'm going to move my purple square off to the side. I don't want you to forget about the purple square, and I'll just leave everything kind of labeled. All right. Now, the other thing I want to draw is a square surrounding this entire image, okay? And this entire square, the area is these 4 little blue triangles plus this purple thing, and that gives me the entire area of this square, all right? So I'm going to put this back over here, and I'm going to leave this, whoops, let me leave my black square off to the side. I don't know why it's not moving. Sorry about that. There we go. Okay, cool. So I'm going to bring these things back in a second. And now all I'm going to do is come over here and I'm just going to rearrange. I'm going to rearrange this blue piece next to this one. And I'm going to arrange this blue piece next to this one. Okay? All right. I'm going to also, sorry, I'm going to move this over. I'm just going to move this down here for right now. I don't want us to forget about this. So the original thing right here, remember, this was the blue triangles plus the purple square made up this guy. Now all I'm going to do is move this over a little bit, and the blue plus the purple will still equal this. Now in the meantime, I'm going to kind of fill in right here with another square. Let me fill in a red square right here. And I'm going to put in another one right here. This one's slightly off, but that's good enough right there. There we go. All right, so for the red square down here, this red one, if this is A and this side is A, then you guys know that the area here is A squared. The area is A squared. So if this is an A and this is an A, the area of this is A squared. And if this is a B, that means this is B and this is B. So we know the area of this thing right here is B squared. So this has an area of B squared. This has an area of A squared. Now, if I bring this back, see how it's the whole entire thing again? So see how my little blue triangles here, plus that leftover space, make up the entire area? So what I can now officially prove to you guys is this right here and this right here are the leftover purple part. So this A squared right here plus this B squared is the same area as this over here, this purple square. So that now proves that this right here, this A squared, and the area right here is B squared. This purple and this purple takes up the same amount of space as this purple, and that is the Pythagorean theorem. And I can prove, again, the Pythagorean theorem to you all. Let me just get a right triangle again, and let's come back to these numbers here. We said that this one was a 3. We said that this was a 4. And we said that this was a 5. So the Pythagorean theorem, all it's saying, y'all, is off to the side, the 3 squared, that's this red guy right here, 3 squared would be 9. That's the red square kind of right here, okay? Then I have this one. This is this side squared. 4 squared is 16. So I have a 9 and a 16. That's the 9 right here and the 16 right here. And we said that it equaled this side squared, which was 5 times 5, which is a 25. And if I take this red and this blue and add them up, that's like taking this red and this blue and adding it up, and it's the same as this purple. So this red plus this blue is the same area as this purple. And that proves it. So now I'm going to come back over here. And this picture, I'm just leaving it here in the notes for you guys so that you can see, once again, I just rearranged those right triangles. And the A squared plus the B squared, here it's the white space. The white space is the same as this C squared space over here. All right, so we've just proved the Pythagorean theorem. Now let's use it to find the missing side of any right triangle, just given the other two sides. All right, so I've got 3 triangles here, and for the first one, If I bust out the highlighter, we can see that I'm given the measurement of 16 for one of the legs, and I'm given the measurement of 12 for the other leg. So we actually have both legs, and we're going to try to find the hypotenuse. So in the Pythagorean theorem formula, which is right here, I've got, it doesn't matter which one you call A and B. Here I put the 12 as A squared, so I'm saying 12 squared plus 16 squared will equal whatever this side squared is. Now we know 12 squared is 144. And we know 16 squared is 256. And I'm saying that if I add those up, it's the same as whatever the area would be of this square over here. So it's c squared. Now let me get the calculator out. It's okay to use a calculator for this. So I'm saying the 12 squared is 144 plus 256. So the sum is 400, which means the area of this square is a 400. So this is a 400, which equals c squared. So now all we have to do is take the square root, because again, if my whole square up here, if the whole area was a 400, if I take the square root of that, that lets me know I've got a 20 by 20, which means I just found the hypotenuse here is 20. So if I take the square root right there, I get a 20, and that means I just found the hypotenuse C. Okay? Move that down just a little bit. There we go. So we were given two legs. You've got 12 squared plus 16 squared equals c squared. When you add them up, you just got to take the square root, and you now found that that missing side length is a 20. All right, let's take a look at this next example. Now in the next example, I'm given one of the legs, but I'm trying to find the other leg. I've also been given the hypotenuse right here, which is c. So notice when I plugged this one in this time, I've got a squared is 9. That's right there. A squared is 9. I don't know this leg, b squared. I don't know this one. But I do know that the hypotenuse is c, which is 15. So I'm going to plug in right here. I'm going to make this c squared. I'm going to make this now 15. All right, now we just need to do the math. So we know 9 squared is 81. And we know 15 squared is 225. Now this time to solve, we actually need to subtract. We're going to subtract 81. We're going to subtract 81. And then we have that b squared is, let's see, this time we need to subtract. So 225 minus 81 gives us 144. So if b squared is 144, then now I need to find the square root of 144. And that means that b here will be a 12. This side length must be a 12. So if you have the two legs, it's really easy because you get to do side squared plus side squared, add them up, and then just hit the square root button in the calculator. Here, you've got to do the hypotenuse squared minus the leg squared to get this other leg squared. So the 225 minus the 81 gave me 144. And remember, I'm just going to kind of sketch it. We're saying that the 144 would be the area of all of this. So now if I take the square root, I get that the square is a 12 by 12 square. All right, and on the third one here with a picture, this time I don't know the leg A, but I have leg B is 10, so I'm plugging that in right there. And we have the hypotenuse is a 14, so I'm going to put a 14 squared right here. Now again, to solve, I'm just going to subtract this 10 squared from this side, and I'm going to subtract 10 squared from this side. So we've got 196 minus 100. It's 196 minus 100, so I'm going to get a 96 right here. So a squared is 96. Now 96 is not a perfect square. We can estimate it, and we can also use a calculator for today. So for 96, we're going to do the square root of that. And I'm going to round it to the nearest tenth. Since I want to round it to the nearest tenth, I'm going to use this 9 to bump this up to a 9.8. That's going to be a 9.8. So if I take the square root of this, that means A would be a 9.8. So it doesn't matter if I give you 2 legs and then you got to find the hypotenuse, or I give you A and you got to find B. It doesn't matter here. Here I gave you B and you had to find A. It doesn't matter which 2 sides I give you. You can use the Pythagorean theorem to find the missing side. Now, the only catch with these last 3 problems down here is that there is no picture. So I want you to use the dimensions to draw a picture after we find the missing side. Notice for the first one, we're going to find the missing hypotenuse. The next one we'll find a missing leg, and the last one we'll also find a missing leg. So for this one, if we're trying to find c squared, I'm going to say, okay, I've got 4 squared. So a squared plus b squared. There's a squared plus b squared. So that's going to equal c squared. This is a 16. This is a 64. When I add these up, I get here, let's see, is that 80? That's 64 plus 16. Cool, that's an 80, and now we just need to do the square root. So it's going to be an 8.9, 8.9. So we have an 80. Sorry about that. That was an 80. And when I do the square root of 80, I get C. And we said that it was, I already forgot, sorry, 8.9. There we go, 8.9. So 8.9 is the missing hypotenuse here. Anytime we get a decimal answer, y'all, we'll just round to the nearest tenth. So we just found C is 8.9. Which means if we have a 4 by 8 by 8.9, let's try to sketch that now together. So I have a 4. I always like to start, there's my 4. And if that's 4, 8 should be twice the length of that. So roughly that. If this is a 4, that's about an 8. And then the longest side here would be an 8.9. So now I can come through and just label it. That's the 4. The side is about twice as long. That's the 8. And this is the longest side we have. That's an 8.9, the hypotenuse. And that's what I mean by drawing the picture after we find all the dimensions. All right, for the next one here, we're going to have that 3 squared plus b squared equals 16 squared. So I'm going to minus 9 on this side because 3 squared is 9. I'm going to minus 9. And I'm going to get here that b squared has to be whatever 16 squared minus 3 squared is. Most of you remember that 16 squared is 256. And now I'm going to subtract 3 squared. So I get a 247 here. And now we just need to take the square root of that number. So in the calculator, I can hit square root. And that'll be a 15.7. So B here is about a 15.7. Remember, if you have 2 legs, you just get to square them, add them up, and then take the square root. If you are missing a leg, like a pirate, you're just going to do the hypotenuse squared minus the other leg squared, and then you hit the square root. And now we're ready to come through and draw this one. So if A is 3, I'm just going to let this be a 3. B we found to be 15.7, so it's almost 3 times as much. If this is a 3, 15.7, a little more than 3 times as much. So I'm thinking like 1, 2, 3. All right, and then that's going to be my hypotenuse. So I can come through now and label this was a 3. This was a 15.7. And the longest side here was the 16. All right, and now we're on the last one here for this video. I don't know a squared, but I know that b is 6, so I'm going to do 6 squared. And I know c is a 15, so I'm going to do 15 squared. I have a hypotenuse and only one leg, so I'm going to just subtract here the 36 from both sides. I'll be subtracting 36 from both sides. So I'm going to do 225 minus 36. 225 minus 36, I get 189. So if I get a 189 here, it's not a perfect square. I'm going to have a decimal. When I take the square root of it, it's going to be a 13.7. So A is a 13.7. All right, let's sketch. So if A is a 13.7, So I've got like a line here for 13.7, and B is only a 6. So if this is almost a 14, this is going to be less than half of this length. So if this is about halfway, so that's, see how that's a little bit less than halfway? And then my hypotenuse is the longest side, the 15. So when I sketched this one, I had a long side here, 13.7. The height here was only a 6. And then this would have been, the hypotenuse would have been a 15. And there's my right angle. Now to practice, when you guys flip over, the questions are all on this side, and you're just going to show the work over here. So see how it goes H, O, S, M? They just line up H, O, S, M. And you will be rounding everything to the nearest tenth. You can see here on the puzzle sheet it says to round everything to the nearest tenth. And whenever you find the answer, you're going to fill in the letter, like letter M goes up here. Letter Y, V, W, X. The letters are right there and they fill in up here. So you just show the work right here, and that's what you're getting ready to do right now. So thank you for watching this video.